Okay. Hey, hey. So let's see. What do we have here? 1, 2, 3. Oh, this one is already modified. 6. No. These are 4. Okay. We're gonna test this one and modify this one as well. But I need super glue as well. Hey Logan. Okay, let's see. Do we have super glue? I mean, of course we have super glue, but do we need this? Yeah. I think that's all that we need. No, I'm lying. We also need this. So, in case you're wondering, of course, today we are going to modify these pneumatic switches. We're gonna test this one. So let's get on with it, I guess. So of course, one of our subscribers, Leon, wants 6 switches for his pneumatic engine for the truck. So we need to modify him six switches. And of course, since I have an order for another engine, we are gonna see about these two. And I need to order, of course, a few more switches, but we're gonna modify this one since we're doing the batch anyway. And we're gonna test this one right away. So let me move you closer so you can observe things easier. Okay. Come on, camera. Okay. Will you focus? Come on. Maybe. Why is everything so dark? I don't know. Okay. Let's first test this one. Let's see why it's there sitting all by itself. Well, we're not gonna do this today because we're gonna just modify the switches, and then when I drill the attachments to them, I need to go to the basement on the grinding wheel to grind the pinholes away. So that's not the scope of this stream today. And I sadly cannot take the camera with me to the basement because the USB cable is not long enough. So yeah, we're gonna skip that part. Okay, let's see. This is fine. This is fine. And this is fine. Okay, so this is a very nice switch. It's a little bit stiff. So a little bit stiff. But, that's not really a problem because all of the switches will be, well, not that stiff. Yeah, that's wait, that's too stiff. Okay, so this switch is, yeah, whatever. It seals, but it's not stiff. Not it's too stiff. Okay, so let's check the super glue. Let's see if I need to cut it a little bit. Residue from previous attempts. Okay. Ah, yes. Okay. It's active. Great. So, first we're gonna open the switches. First, we're gonna open all of the switches. Now you're gonna see, of course, why this is the way it is. So that's one of the reasons. Okay. Looks to be a little bit there. Who would have thought it let go? Okay, 6 more to go. And it's one of the things I do not like to do because, you know, I think it's because of this that I have a pain in my shoulder. So every time, you know, when I have to cut, I stretch this muscle and it really hurts. So bear with me here, because I specifically when I cut this, this and the middle part, you know, and since I'm a right-handed person, if I do it with the left hand, I don't think that's gonna be. Yeah, no, I have no feeling in my left hand, sadly. So I'm gonna deal with the pain, brace myself a little bit, and it'll be fine. Just have to make sure that I don't cut myself. There we go. Ah, yeah. Okay, that was painless. Okay. Yeah, we don't want this to happen again. I don't quite remember what I did last time that I cut my finger, but I'm sure I didn't open the switch. But since my memory is that of a goldfish, you never know. So let me explain what we're doing here. We're basically, since this rear part is glued in place from the Lego factory. It's one thing is here in the middle, and then it's glued here, and here. I mean, glued. This is a part that has tabs and stuff, but it's really impossible to get it out without cutting the tabs. Sometimes when you're lucky, it happens that's really few and far between. Well, I am not a football fan. I don't give a shit about football, but if you like football, please. I'm pretty sure it's more interesting than this stream. Except if you like to see me suffer. See you. There we go. Final one. This is, of course, the worst part of modifying the switches. I hate this part. This is my most dreaded part. There. All switches are open. Let's move to more merry proceedings. So let's take, I don't know, let's take this one. What happens now? First the light goes out. Okay, first we cut off this little tab, whatever is left of it, and then we need to clean up the cover, you know. We clean up these here. So our goal is that it needs to sit really flush against this backplate. I mean, the backplate needs to sit flush against the body, and for this we need to, of course, cut away all of the tabs because we don't need them. And here's another example why my desk is the way it is. And there's really no point in me turning the desk around to make this surface clean, because it's gonna be destroyed in a matter of well, not days, but in a month it's gonna look the same. And now that I remember, it could have been that I modified the switch and I cut myself. Could have been, or maybe not. Okay, this is reasonably good. Now here, what we're doing next, we're gonna remove the rubber thingy, and we're gonna cut two incisions here into the lever. These are gonna be so that the air can escape more easily when the cylinders exhaust. So like this. It's really not important that they are the same. It's just a cutout has to be there. I'll show you what I mean. Here, you see the inlet here. When the used air comes from the cylinder back, it exhausts through the open part of the switch. And well, when I move the lever down, you see, then this whole, come on, focus. Oh, really? Focus, camera, man. Okay. So, you can see the small hole. So this hole here gets exposed, and the air rushes out here. So, and I'm making the incision here so it can rush out faster. Okay, what we do to the body? To the body, first we cut out all of the excess here. Come on, we have to cut out the excess of the backplate, and then we get rid of these tabs. These tabs are basically responsible for the switch clicking in each of the 3 positions. And of course we need to clean this here because this is going to prevent us from pushing the backplate far enough to get a seal. So and we're gonna check with the backplate, of course, if the surface is clean enough. So we want, basically, it needs to sit flush here on both ends. And here at the bottom, see, we want this to be slightly recessed. So it's okay on this side, but on this side it's still a little bit too high. So what's the reason? The reason can be this edge here. Okay. And of course the edge here. I'm gonna go into detail here, but on the other ones I'm just gonna, cut away. Okay. Well, the internals of the switches is the same. It does not matter. The internals of all of the switches of this generation is exactly the same. It doesn't change. What changes is basically just the switch body. And the very old switches, the problem with the very old switches is that the light gray switch bodies, or the last generation light bluish gray switch bodies, are made of a very brittle plastic. And since they are so old already and brittle, the inlets here they are not stretching anymore, and they can break off easily, crack, and then your major source of leaks is here with the inlets. And of course the body itself is much more brittle, and I really don't like to work with them. It's easier to take these, and I glue various attachment points to them anyway, and I think this is a much a cleaner way. We have to move with the times. I think my blade is a little bit dull. You mean the new switches? These ones. Where are they? keys. To be honest, I have not used these switches at all. I think I've taken one apart. Don't know which one. Or no, I haven't taken one apart. I have just watched a video on how it's done. I don't know. I mean, they cannot be easily modified. But let's see. The ones that I'm making and the ones that are the original ones, so from 1987, the internals are exactly the same. They are not more irresponsive or not more anything. They are exactly the same. I know because I have modified a shit ton of them. So they are exactly the same. There's no difference at all. The internals on all of these switches is basically the same. The differences are not worth mentioning. So, okay, it's moving freely. Now we bore. I use I think it's 1.8 millimeters drill. I buy the switches on Bricklink. The problem is that I have to buy them from a source, of course, that has enough of them, not just one or two. You can get one or two switches for ridiculous prices, but those are, I don't know, like €1 to €2. I mean, they're not that expensive. The cylinders are much more expensive. I don't know. I have ordered the new ones to test. I don't know if what I'm gonna use them for or if I'm gonna use them at all. But you know. So now obviously once they are drilled, you will see that the drill holes need a little bit of cleaning up. My god, camera, will you focus? Whatever, you see the burrs. Yeah, whatever. Whatever. So I need to clean out this. And usually when you bore, there's a slight edge here on that. And then I use a very flat screwdriver to basically get rid of this edge, because if I leave this edge as is, it's gonna destroy the rubber in the switch. How do I know? Well, please don't ask. One way I used to modify the switches in the old days, but this was basically just one batch, not for a customer, for a test engine that I did. I wanted to make the inlets bigger, and I didn't open the switch. I just bored from outside to the inside of the switch, and well, the results were predictable. So yeah. I destroyed the rubber. There were obviously burrs here on the inlets, and of course the burrs, whatever I didn't destroy with the drill. When the switch was switching back and forth, the edges on the holes were destroying the rubbers, and the rubbers didn't seal here in this part between the compartments, and of course the switches were leaking. So yeah. Yeah, maybe, maybe, maybe. Ah, yes. Okay. Well, so you can clearly see the surface. Surface is nice and smooth. Never mind the scratches. The scratches are completely irrelevant and are very shallow. The rubber more than makes up for the difference. Especially when you then lubricate everything, it seals like a pro. Even now that when we are gonna glue it together, it's gonna seal perfectly. Okay, so um, yeah, so let's seal the switch. So first we test again how the backplate sits. Okay, so the backplate, as described before, see, oh come on, well, you can see that it's slightly recessed here, so it's a little bit lower than the edge. This has to be the case because you see the back plate presses against this part, and this is the part that's doing the sealing. Okay, so if the lower part here, this compartment here, is not pressed enough against the lever, uh, there's no sealing. So the lever can flex a little bit, and then of course there's no contact between the rubber here and the body of the switch. So this is a major source of leaks when you take the switches apart, is that the back plate does not sit well against the lever. So how do we glue this? I have my my very well worn and covered tool here, sacrificial brick, Technic brick. Um, so how do we do this? This needs to be covered, and this needs to be covered, and this. And of course we dab a little bit of glue here and a tiny little bit here. Then we press everything down, and we use the sacrificial brick, and we press. Now we wait. Now we wait till everything is glued together. Then we put everything on the side and do the next switch. And after the next switch is done, this should be dry enough for us to see if it's sealing. Well, David, as you mentioned it, we can make, now that we know that I have the new switches, what if we we can do this depending on how fast I do those. We can take apart one of those new switches, modify it so it doesn't have the tabs and moves freely. And we can maybe do one cylinder or two cylinder pneumatic engine with those switches. To see how it performs. Okay. Is it? Yeah, it looks like it's fine. I always look. It has absolutely if the back plate is not lower than the edge here, it's not gonna seal. So it has to be lower. Acetone. I have not tried it, I must admit, but I think there's acetone in the super glue as well. So, I mean, you can experiment with it. You can experiment with it. Okay, so switch is glued. Let's set it on the side. Yeah, maybe. I mean, I need the glue applied very precisely, and acetone. I don't know. I would need to experiment with it if you know if it can be applied precise enough. I mean, well, as it happens, I have glued backplates before, and no, I will explain. Let me explain the reasons for this while doing the switch. Okay, so let's first modify this. Of course, there's crud in the switches as well. The thing is that when you would screw it in the central position, which I have done, of course, in the past, I may even have some switches here that are modified like this. The problem is that then, as I talked before, the only clamping force is in the middle. But the middle is not really the clamping, the area where we want to clamp it. We want to clamp it here. See? The back plate needs to press down against the lower part here. So this is where the sealing pressure needs to be applied. That's why I glue it here. So this needs to be pressed down. This part, this top part, while it needs to sit flush against these, the important part is here. If this is not pressed enough against the body, it's not gonna seal. So if you just screw it in, you don't get any pressure or not enough pressure here, and it's gonna leak like there's no tomorrow. But you know, gluing is really easy, and it's also easy to unglue it, so I don't see a reason why you would bother even with screws. And I always turn this rubber around, so I don't use the surface that it was running on when the switch was assembled by Lego. I turn it around and use the fresh surface, like this. This is fine. So all we need to do with this is making holes, and we need to clean this guy here. I mean, don't get me wrong. You can use a screw in the middle, but not just the screw. You need to glue it as well. The screw can be just a crutch, so a helper to make it seal a little bit more. Okay. Okay, and the bottom I'm not happy with. No, not yet. It's usually in the corners that doesn't want to sit flush, and then it doesn't. Okay. Yeah, there we go. That's fine. Okay, let's go. There we go. Let's assemble. There we go. And now we wait again. Depending on the mood of the super glue, sometimes you know, it grabs immediately. Sometimes it takes a while for it to get hold of it. And if this was a YouTube video where I made the content beforehand, I would, at this point, I could just do this and everything would be done by the magic of editing. But that's not the case. So instead of being able to skip forward to the finished product, we have to go through it, through the motions. Okay. Yes, this is fine. Now let's test the switch that we made earlier. How do I test? But basically, I block off the outlets, and then I use just a simple pump that I'm of course modified the inlet broke, of course, and I had to then insert a piece of tubing, glued it shut. I just put it on, and then I pump, and when I see the pump stalling, so when the pump cannot pump anymore, then the switch is fine. But when instead of the pump making stalling noises, and I hear hissing here from the switch, then we have a problem. So let me shut up and let's listen to what's happening. We have a problem. You can clearly see, clearly hear that the switch is leaking. And I can clearly see where it's leaking. So this spot here is a little bit too high, and it's leaking exactly here in this area. So we're gonna have to repair this, and let's test the one that we made just now. See, this is the noise I want to hear. This is the noise I want to hear, and now we go, of course, through the motions. Yeah, this switch is fine. This one, however, we need to take it apart again and re-glue. No biggie, since super glue is relatively brittle, we can get this off without much worry. There. It was exactly in this corner here that it didn't grab very well. So now we have to clean the edges. Obviously this hasn't happened the first time. Every now and then a switch, my god, sometimes I think I cannot talk anymore. Sometimes the switch is gonna leak, and that's just part of life. And usually when I do this and then reglue, the surfaces are even better because it's pre-etched by the previous application of the glue, and then the glue has a better key and grabs a little bit better. Mm-hmm. And now wait. We only have to repeat this 5 times. And you see, this is a reason why I don't sell the switches anymore as a modified part. Simply because it takes time, patience, it's boring if you've done this hundreds of times. and the margin is really small. So I don't know. I think it was like €5 that I wanted for the switches modified, and I bought them for like 2.5. So it was like €2.5 per switch. I mean, I rather watch a YouTube video than do this if I can. Okay. I have a bad feeling about this, but let's try it. The gaps here are a little bit too big for my taste. Let's see. Yeah, of course. That was obvious. That was pretty obvious. Okay, third time is a charm, right? Should be fine now. This could be the best switch yet. And how was your day? I wonder where JSP is. He's probably in the sauna. Okay, these are now much better. Much better. Okay, I'll let this one sit over there, and let's do another one. I used toothbrush, by the way. Best tool in the world. Mhm. Ah, this one looks good. JSP, hello. Back from the sauna. Yeah, sure. No biggie. Okay. So let's test this one now. Let's see if it's any better. Nope. It is leaking. This switch is leaking. Let's inspect it a little bit further. I see no defects here. But what could be the case is that, well, you cannot see it. It's there. There is a mark here. There is a mark here that is a little bit deeper than I would like. And it could be that this is the case. I mean, this is a reason for it leaking. Let's see if we have a spare. Yeah, but not in this case. That's not gonna help. Do we have a spare? And the answer is maybe. This one is pre-drilled. Looks fine. See, this is one of the cases that I used a screwed on. Oh, another one. I mean, you see, I have many spare switches from decades past, you know. So these are very brittle, these switches, and the insides are exactly the same as this one. So yeah, I think we'll go with this one here. With this switch body. Let's see. It's already, yeah, very nice. Very nice. Very nice. Okay. It's already it has already the pinholes are already removed. So let's see if this is attaching smoothly. And then we can glue and try it on. I don't know, buy pneumatics. I don't know. They're not that expensive. It all depends on what you want to do. Alright, so we need to do some cleaning up here. This body has super glue residue, so we need to clean up a little bit before we can glue our new piece in. I wonder why it's there. I of course forgot why I put it there. Maybe I have destroyed the rest. Maybe the back plate broke or whatever. Okay. Needs some more persuasion here. Yeah, this body is not good. This isn't really doing good for me. Let's see, do we have another one? Yeah, we can use this one. I think this one's fine. Yeah, this one's gonna be fine. Is it the same color? Yep, it's the same color. Okay, so this one's gonna into the spares, and we're gonna use this one. Looks much better as well. Okay. Okay, it fits in nicely. Oh, oh shit. Now I know why it's there. You see, when I was cutting, oh my god, it's focusing on everything except what it should. You see the cut here? That's why it's there. My god. Okay, so that's no good. Okay. Let's find out why this one is there. What's wrong with this switch? But what did I do wrong here? Okay. Nothing really, but the surface here is very smudged. Why is it so smudged? Hmm. This is something I don't want to happen. For fuck's sake. That's super glue all over it. Oh well, the important thing is that it seals. Everything else is secondary. Yeah, I'm aware of this, Leon. I'm aware of this. Don't worry. I know what you're up to. They are going to be mirrored. Okay. So, as Ace Ventura would say, very well. Then, 3 switches are done for it to go. No, there's not gonna be a any Sierra action today. If I do those switches, I'm happy. Maybe we can disassemble one of the new switches, because I forgot how it looks inside, and I want to see if I can make it without the notches. But first I want to get these out of the way. And one of the things why we're doing here is so that everybody sees how long it actually takes to properly make good switches. And well, and I want to explain what steps are there to make. Oh, for fuck's sake. And of course, everybody who watches this should by now be, I mean, after watching this, should be able to, make their own switches. That's also one of my goals. I want to give you the tools where you can do your own. So I don't have to. Well, we are at about the half mark as well. It didn't go without issues, of course, as it never does. It's always one of the corners. I have to sit flush. No, I have to sit good, otherwise there's no sealing. Okay. Holes. There we go. Which ones? I mean, the stock for the cars that we use here, it's the stock size. Otherwise, I use also. I mean, stock 1 to 10 or 1 to 8. No, 1 to 8 scale wheels. So we can measure them. Michael, did you ask me in a YouTube video what the diameter is before? Because I forgot to answer it, of course. Let me just glue this and I'm gonna go and measure it. I don't know from memory, but I think it's like 92 millimeters or something like that. So they are a little bit bigger than the Lego wheels. Okay, then let's answer the question immediately. Just this needs to dry enough so I can let go. I'm not happy with this corner here. This is good. This corner is bothering me. Moisture also helps the super glue to glue. So there we go. Sometimes I wish I had a mini clamps that would allow me to clamp this together. Yeah, that's a fail. Anyway, let's take a look at the wheels. So wheels are 10 centimeters are there are 10 centimeters across. As a comparison, see that's the Land Rover wheels. These are the Land Rover wheels, and the Land Rover wheels are like 81 millimeters across. So these are 2 centimeters more in diameter than the Lego wheels. Well, these switches are not all for an engine that I would sell. 6 of them are for Leon, and the rest is for an engine that I am building. Yeah. So let's test this guy here. Perfectly fine. Perfectly fine. So we have 4 good switches. 3 more to go. And this one looks very nasty. Looks like super greasy. There's one more type of wheel that I am also using, and that wheel is a little bit bigger than the one in the Mustang, and it's basically a modified, well, not modified, it's a proper tire from 1 to 8 scale model cars. I mean, model cars, RC cars, on a truck wheel that is made narrower. So it's been cut in half, and it's the opposite of bending. So a middle section has been cut out, and then the wheels have been glued together to be more narrow. Let me show you. It's basically the wheels that I... Oh my god, this is so huge. I'm not used to this shit. Basically what I did on the Challenger front suspension. So these are even larger. You see? These, compared to the Land Rover wheels, are like, you know, it's ridiculous. And these are like, what are they? They are 11 centimeters across. So 1 centimeter larger than the Mustang wheels. And of course, this is the you know this suspension from one of my videos. I mean, I completely forgot that I have this here. It's dusty and everything, yeah. So it's a multi-link setup, of course, with all bionicle joints. And this is really, I mean, really sturdy. Like, really. There's There's like no slack here. Minimal. And of course, this needs redoing because I learned a lot more about how to do this. But yeah, we'll see. I mean, I probably never gonna finish a car out of this because it's gonna be too heavy. It's gonna be way too heavy. But the nice thing are the turntable wheel hubs, to which I have a 3D printed piece that's holding the wheel. So yeah, we'll see. Yeah, where were we? Yeah. With the switches, it's like once you hit your stride, it goes kind of quicker. First, 1, 2, 3 maybe are slow, and then once you made a little bit more, you get into it again. I'm just gonna drill off camera. Hmm. Come on. And on Friday we then continue with our regular programming with Sierra. I am ordering tomorrow, probably ordering some parts from Bricklink, so I can finish the charger. You know, the color to have it a little bit more color coordinated, and then I can start making building instructions for the charger. I've decided that the seats in the charger I'm gonna make them, you know, just basic seats for now, and not gonna worry about too much, just so that it looks fine. Perfect. What I find interesting is that I encounter like two kinds of material in those switches. It's like Lego changed the plastic type in those. One of them is a little bit softer, one of them is a little bit harder. off-screen action. Make a picture. Which one is it? A convertible, two-door, four-door, touring? What is it? What kind of engine does it have? Don't tease me like that. Well, Ben, the Challenger was kinda abandoned. I mean, I still have the front and rear suspension as I shown you in here in a couple of minutes ago. But I don't know. It's just too big. I mean, I don't know. It would be very big and heavy. Maybe I'm gonna tackle it one day. One of these days. But there's other projects that we have lined up. So a two-door limousine, okay? Because with the E30, I'm very particular. You have the two-door limousine, four-door limousine, convertible, and touring. Well, limousine, sedan, two-door sedan, four-door sedan, and touring and convertible. Yeah. What's gonna suit it perfectly? So it's big and heavy. Yeah, you have the Charger for now. There we go, perfect switch. One more to go, and then we can see about the new ones. I'm eager to see how they look inside because I forgot. I saw a video and yeah, of course, I don't remember how that looks. Well, I wouldn't mind a Challenger as a daily driver, a new one. I would totally rock it. Sadly, they are not being sold here in Europe, so I don't even have a chance of getting a used one here. I could import one from the States, but I've seen a few of them here as a gray market imports driven by some shady people. So I don't know. And they all look modified to shit. None of them is stock, of course, because all of them need to be pimped out. That's the reason why they were bought in the first place. So yeah, chances of me owning one are very slim. As a die cast model, maybe, or if I do my own in Lego. But you know, I am my goal for next year is to put the E30, the real life E30 back on the road. That's gonna be a great moment when that beautiful inline six cylinder sings again. That's really a nice sound. Love it. I don't know if it does, if it shows that you're a Euro American, Euro Japanese car guy. I mean, I'm a car guy. I like cool cars, no matter their origin. I like German cars. I like Japanese cars. I like American cars. I even like French cars. So, well, I just like cool cars. I'm not a fanboy of any particular brand or car. I do prefer rear-wheel drive or all-wheel drive though. That's where the fun is. But other than that, the nation of origin is irrelevant. Oh, perfect fit the first time. Perfect. So this is the last one. Finally. Mine is a 325i, yes. M20 B25 engine. So it's not the fastest or the most powerful engine, of course, but I really like the sound. How many? What? How many pressure a perfect switch, as you say, can take before link? Before. You mean how much pressure the switches take before leaking? I don't know. Really, I don't know. But you have to keep in mind that if you have, for example, 4 switches and you put in like 8 bars into the engine, each switch is gonna be, you know, like it's gonna have to deal with 2 bars. And of course, since everything is constantly moving, the switch immediately passes the pressure to the cylinder, so it doesn't have to resist the pressure constantly. So I don't know. I mean, I had like engines with like inline 3 engines with 8 bars of pressure running like what I had 2400 rpms was the best one I had, and maybe the switches started leaking then. I don't know. I cannot even tell. But the engine was running beautifully. It was powerful, and as long as the engine has power, nothing is leaking. Because as soon as things start leaking, the engine loses power. So I don't know. I mean, someone could measure it. That someone's gonna not be me, because I cannot be bothered. Perfect switch. There we go. We have done it. We made like 7 perfect switches, and of course we have some. This is spare parts. Now let's clean up this mess a little bit. Then we can open up a new one. There. Who is bothering me? Oh. Okay. So let's open up a new switch, because I'm really eager to see how this looks inside. Now, I have actually no idea how to open it. Obviously, we're gonna have to remove this plate. Or not. No, wait. We have to remove this plate. Have to remove this plate so that we can remove the lever. Oh god. Okay, let me, before I butcher this completely, let me how to open one of these. Let's see how to open internals over. Okay, let's see. So this is green gecko Lego tech. Let's make some promotion for him. Okay. Yeah, blah blah blah. Don't care about that. So okay, so let's pause this a little bit. Okay. So obviously we have to, here is something, here it's glued here and here. Okay. Interesting. So there's no way to pry it apart as easily as we did with the old ones. Okay. And I see that the locking mechanism is somewhere here. Damn it. Okay, I mean, let's apply some force. So obviously now we know it's glued. I mean glued. It's fastened here, 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 and here. Well, we're gonna destroy one anyway. Yeah, could be that he did, but I don't care. I mean, I'm doing this not to have a monopoly on my designs. I mean, that's why I'm putting them out. That's why I'm showing you stuff like this, you know, so that someone else can do it as well, not just me. Lego did it really well here. How do you even disassemble this without? How did he do it without destroying everything? Because I mean, I want to reglue this. I don't want to destroy it. Yeah, I'm already destroying it. I mean, once we disassemble one, of course, we're gonna learn a lot. It's one thing, but watching a video and then seeing yourself. Maybe there's a better way of doing this. Yeah, I mean, let's destroy it. What the fuck? This, okay. So this here is not essential anyway. No. The way I see it, this part here does not carry any load or weight or whatever, so we can get rid of it. Same goes for this here. Now that we know. I can already see those being a nightmare to modify. I don't understand this plate here. Maybe it's gonna be obvious once we disassemble it. I don't see a justification for it being here. My god, this is really glued shut. Look at this. My god, we cannot win this, you know? This is really... Yeah, those switches are never gonna find their way into my pneumatic engines. Not the way I see it here. Maybe there's a way of, well, I don't know. a way of us not using this back plate, but this is just horrible to take apart. Oh, come on. Perfect way to injure oneself. No, 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 you don't understand. This switch is a lot more complicated than the regular ones, and even there, with the simple ones, I wouldn't drill just holes. You destroy everything inside, and it's not just the holes I want. It's come on, ah, come on, really. Oh my god, this is complex. Okay. So, okay. We can remove this easier by basically cutting here and cutting here. Then we bypass the supports here. And we can cut here, and we bypass this. Okay, so this is solved. So taking it apart isn't that difficult. So when we disassemble it, you can see why it's impossible to modify. So bravo Lego, yeah, making stupidly complicated switch that no one needs. So first of all, even if we drill those, we did nothing, because the way Lego decided it, this probably covers pathways. I mean, we're gonna destroy the switch completely, so fuck it. This covers some pathways, and I'm probably gonna drill this here out. Maybe loosen it. No. Okay. No harm done. No harm done. I'm unharmed. Just so that we see what's behind this. The switch is gonna be completely destroyed, but fuck it. What? Looks like this is molded on. But anyway, we don't need to take it apart. It's obvious what's happening here. So we have just basically holes here, and then there are 3 paths down into the outlets. And then we have this overly complicated switch here that's made similar to the old one, just, you know, a bigger version that's then sliding here, and the slider, so the notch is here. The problem is that yes, we can remove the notch, but we cannot make the air pass easier through it because we have no way of drilling holes here. So this is, it's not easily modifiable. It is easier to mount in some applications because you can stack them together. You know, you can have like 3 switches in a very tiny space, and all are being connected, compared to before where you have hoses running on this on the side of the switches, so you cannot stack the switches together. That's understandable, and those switches have their use. Absolutely, they have their use. I would have done it differently. I would have a rubber seal here somehow, and then have it directly connected to this. Basically, I would have this here that would be just stretched over this, and it would basically perform the same thing. And this would be the sealing surface, and if this was the sealing surface, then the this the pressure of this would be irrelevant, because the only thing that would matter is that it's held in, by the bearing that's keeping it in. So it would be, I don't know. I mean, the engineers at Lego probably looked at it and said that would be reliable. I don't know, but that's how I would have made it. I would not make the surface here. I would make the surface here. So the sealing surface would be here, and then the holes would directly connect to this. So there would be just straight holes. Doesn't matter, because I would only enlarge those holes, but there's like passages going down there, and I cannot enlarge those passages. Those passages are as small as this, and they would be the choking point. So there's really no point. I mean, they meant good, but the execution is really poor. I mean, it would be so nice, really so nice, if these here would be connected directly through here, and then this would be the sealing surface with the seal and the compartments. That would be so nice, and much easier, much easier. This would be so much easier to seal. Yeah, basically. Yeah, basically. I mean, I would have the surface here would have to be a lot smoother than I could 3D print it, and of course I have no way of reproducing a seal that would be suitable for this. Lego would have, but they decided not to. So yeah, I mean, it's a cute design. It's good for machinery, but it's not good for engines, sadly. I mean, this hole here has so much potential for doing stuff on for reciprocating engines. The crank could be the crank or cam could be connected directly to this, and yeah, would be simpler, but no. Nope, we can't have it. We can't have it. It could be like this would be the inside of the engine. This would point inside. The cam would be in the center of the engine, and then we would have like the inlet and then the outlet to the cylinders on the outside, and you could have like a really compact arrangement. You could have them stacked. You could have them stacked like this, or something, and have reciprocating rods here on each one of them, and then a central crank going here in the middle could actuate them, or something. I mean, there would be options. And of course, the main idea, of course, with Lego was so that they can be stackable like this, and then you have your outlets here. This is impossible with the old switches, of course, because with the old switches, you have to leave at least, I mean, at the worst case, You have to leave 2 studs in between if you want to stack them. I would prefer 3, so that the hoses can be can run a little bit, have a little bit more freedom to be routed. So I mean, in this instance, these are a clear improvement. But yeah, they are not for engines. Definitely not. 2 reasons. First of all, they the point where see, you cannot remove this, the notch, and I mean, I guess it's a power loss. It's a clear power loss. You can feel the notch, and it's pretty substantial. And of course, the airflow is gonna be reduced because of the small inlets. I mean, one can make an engine, of course, out of this. It's gonna run, but it's not gonna perform the way you're gonna leave like 50% of performance on the bench because of this. That's the problem. Absolutely, you can make an engine that's gonna run on these, no problem. You can make an engine that's gonna run on unmodified regular switches, no problem. But we're not modifying because the engine wouldn't run without us modifying it. We're modifying because we gain so much more performance out of the engine. That's the reason. So yeah, unless I can gain performance out of this, there's really no point of me using it. And I think you agree. I think you agree with me. So yeah, that's the adventure of us disassembling this fucker. Yeah, I'm gonna throw it in. Don't need it. Okay, so what can I say? That's it for today. I'm going to grind off these and glue the bricks on for Leon, and then send everything to him on Friday probably. And of course, I see you on Friday. I think. I hope. And on Friday we are going to continue with the Sierra. In the meantime, you know the drill. Do consider supporting me on Patreon, because this shit is expensive. The charger instructions are gonna be ready probably in 2 weeks ish. We'll see how fast Bricklink, the parts from Bricklink are gonna arrive. Yeah, and I see you on Friday. And thanks for having the patience of watch me modify the switches. The most boring, tedious task in the life of Lego Pneumatic engine. See you.